A pleasant good afternoon to one and all. This is Maria Pushpam, and for today's class we are going to see the continuity of coulometry. So previously we have seen electrogravimetry, the details belonging to that is principle, instrumentation and application, and for today's class we are going to see the continuation of coulometry. And coulometry we have seen constant current coulometry, and now for today's class we are going to see controlled potential coulometry, or it's otherwise called as potentiostatic coulometry. And we have seen the principle behind this potentiostatic coulometry, and now we are going to see the apparatus setup. So coming to the apparatus setup, the components present in a controlled potential coulometry are a coulometric cell, a potentiostat, a coulometry assembly, a current measuring device. So these are the four different components of this controlled potential coulometry apparatus. I'll repeat: coulometric cell, potentiostat, then coulometry assembly, then current measuring device. So first we can see what is said to be this coulometric cell. So it is provided with three electrodes: working electrode, which is nothing but the cathode, the reference electrode, that is standard Coulomb electrode, and the auxiliary electrode, or is otherwise called as counter electrode, which is nothing but our anode. I'll repeat. So it is provided with three electrodes: working electrode, which is our cathode, reference electrode is standard Coulomb electrode, and auxiliary electrode, which is otherwise called as counter electrode, which is nothing but our anode. And the counter electrode is separated from the working electrode by means of a sintered glass flint. Is it okay? Now coming to potentiostat. So potentiostat, it's a device used to control the potential of the working electrode. It consists of a variable voltage source as well as an electronic control link. A variable voltage source as well as a electronic control link. And third one is a coulometer assembly. It's a device to measure the quantity of electricity passed through the device. And last one is current measuring device. It is nothing but a milliammeter. So these are the components present in control current, that is control potential coulometric apparatus. Four components. First one is coulometric cell. It consists of three electrodes: reference electrode, working electrode as well as counter electrode, and the counter electrode is separated from the working electrode by means of a sintered glass flint. And second one is potentiostat. It is nothing but it's a device to control the potential of the working electrode, and it consists of a variable voltage source as well as an electronic control link. Third one, a coulometer assembly, which is a device used to measure the quantity of electricity passed through the device. And fourth one is a current measuring device, which is nothing but a milliammeter. So this is a setup of the apparatus. As I said you, three electrodes are there. One is said to be the cathode, that is our working electrode. Anode is nothing but our counter electrode, and the middle one given at the bottom is nothing but your reference electrode, that is standard Coulomb electrode. You have a potentiometer connected to the cathode, which makes the potential constant. The anode is connected to a resistance wire, which is in turn connected to a battery DC source. Okay, and application of this method is, we have three different application. The first one is a lead in presence of cadmium can be determined, then copper in presence of bismuth can be determined, nickel in presence of cobalt can be determined. You can see first group or second group or third group elements. You can separate the thing identically. If you are in need of lead, if it is mixed with cadmium, you can find separately the lead present in presence of cadmium, then copper in presence of bismuth, also nickel in presence of cobalt. These three can be estimated. Then coming to the alloys, composition of any alloy can be determined by this method. The example given here is composition of the alloy containing silver, bismuth, cadmium and antimony can be determined. Third one, trace amount of elements can be determined. very small amount is present in a sample, that can be determined. For example, elements such as uranium, polonium can be determined if it is present in trace amount also. Is it okay? So these are the three different applications of control potential coulometric methods application. Three things. First one is lead in presence of cadmium can be determined, copper in presence of bismuth can be determined, then nickel in presence of cobalt can be determined, then composition of alloys can be determined, then elements such as uranium and polonium can be found if they are present in trace amount. Next thing we are going to see is the application of the first method. The first method is nothing but constant current coulometry. So I have said you coulometry in this method, just by measuring the current you can find what is the substance present there, you can detect. So in coulometry it is purely based on Faraday's first law. In the previous method, electrogravimetric method, we are determining the quantity of current will be proportional to the amount of substance present. So from that we determine. And second method, the substance can be determined by measuring just by measuring the current. Is it okay? So in coulometric titrations, if you take coulometric titration is nothing but it's a primary application of constant current coulometry. So constant current coulometry can also be called this coulometric titration. So as I said you earlier, coulometry are of two types. One is said to be constant current coulometry and second one is controlled potential coulometry. And the thing we have seen for today's class, first we have seen constant potential coulometry or control potential coulometry. We have seen completely the apparatus setup as well as the application, and now we are going for coulometric titration, and this is the application of the first method. First method is nothing but constant current coulometry. Is it okay? And that constant current coulometry can also be called as coulometric titrations. Is it okay? I'll explain in detail. So coming to constant current coulometric analysis, it can also be called as coulometric titration. If you take this technique, we are using the term titration, although the titrant is not added as such from the burette. We are not using any burette. The reagent is generated by the electrode reaction involving loss or gain of electrons. The amount is evaluated from the knowledge of current strength as well as generating time. I have said you yesterday, Q is equal to I into T. Q is equal to I into T, where Q is nothing but the quantity of electricity supplied. It's given in coulomb. I is the current strength and T is the time taken. What's the time duration taken for passing this current? So these measurements are used in this coulometric titrations. Okay, and the electron becomes a primary standard in this coulometric titration. So why we call this coulometric titration? Here we are not using any titrant, though we call it as a titration, because the reagent is generated by the electrode reaction involving loss or gain of the electron, and the amount is evaluated from the knowledge of current strength and generating time, because Q is equal to I T. Okay, if you take the types of coulometric titration, there are two types of coulometric titration. The first one is called as primary coulometric titration and second one is called as secondary coulometric titration. I'll repeat. So previously I said you coulometry is classified into two. One is constant current coulometry, another one is controlled potential coulometry. And next we have seen, if you take this constant current coulometry, it is otherwise called as coulometric titration. That is, application of constant current coulometry is called as coulometric titration. Coming to coulometric titration, it's a titration where we have two types. One is said to be primary coulometric titration, other one is called as secondary coulometric titration. Coming to primary coulometric titration, if you see here, the substance is estimated will undergo direct reaction at the electrode. Inga intermediate la form pannadhu, direct reaction will take place at the electrode. The substance which is to be estimated undergoes direct reaction at the electrode. The good example given here is nothing but your ferrous ion is converted into ferric ion plus electron, and the completion of the reaction can be detected amperometrically. By using an ammeter you can find this. Okay, I'll repeat the point once again. So what do you mean by primary coulometric titration? These are titration in which the substance to be estimated will undergo direct reaction at the electrode. It will undergo direct reaction at the electrode. And a good example is given here. It's nothing but oxidation of ferrous ion to ferric ion at the anode. So Fe2 plus gives you Fe3 plus electron. So the completion of the reaction or the end point can be detected amperometrically. Is it okay? And coming to the second one, second is called as secondary coulometric titration. So coming to secondary coulometric titration, if you take this type of titration, here an active intermediate is first produced at the working electrode. An active intermediate will be first produced at the working electrode and then reacts with the substance to be estimated. ஃபஸ்ட்டுக்கும் இதுக்கும் என்ன வித்தியாசம்னாமா ப்ரைமரி coulometric டைட்ரேஷனில் நம்ம எந்த சப்ஸ்டன்ஸை எஸ்டிமேட் பண்ண போகிறோமோ அதே டைரெக்டாக வந்து என்ன பண்ணோம் எலக்ட்ரோடில் வந்து ரியாக்ஷன் அண்டர்கோ பண்ணி உனக்கு ப்ராடக்ட் கொடுத்துடும். ஸோ அதுலேருந்து என் பாயிண்ட் வச்சு நம்ம ஆம்பிரோமெட்ரிக்கலி வி கேன் ஃபைண்ட் வாட் இஸ் அமௌண்ட் ஆஃப் சப்ஸ்டன்ஸ் ப்ரெசன்ட், வாட் இஸ் அ சப்ஸ்டன்ஸ் ப்ரெசன்ட். ஓகே, இங்கே பார்த்தீங்கன்னா செகண்டரி coulometric டைட்ரேஷன் அப்படி இல்லை. ஒரு இன்டர்மீடியேட் வில் பி ப்ரொடியூஸ்ட் ஃபர்ஸ்ட். நமக்கு ஒரு ரியாக்ஷன் ஃபார்ம் பண்ணால் முதல்ல ஒரு இன்டர்மீடியேட் வந்து ஃபார்ம் ஆகும். அந்த இன்டர்மீடியேட் வந்து நம்ம எஸ்டிமேட் பண்ணக்கூடிய சப்ஸ்டன்ஸ் கூட ரியாக்ட் பண்ணி அதுக்கப்புறம் தான் நம்ம அதை வந்து நம்ம எஸ்டிமேட் பண்ண முடியும். பொட்டன்ஷியல் ஸ்பெக்ட்ரோ ஃபோட்டோமெட்ரிக்கில் நம்ம அதை எஸ்டிமேட் பண்ணுவோம். இஸ் இட் ஓகே? I'll say the second method. Second is called the secondary coulometric titration. So in this method நம்மளோட சப்ஸ்டன்ஸ் வந்து டைரெக்டாக என்ன அண்டர்கோ பண்ணாது, ஒர்க்கிங் எலக்ட்ரோடில் வந்து ரியாக்ஷன் வந்து நடக்காது. ஃபர்ஸ்ட் என்ன நடக்கும்னா an intermediate will be formed first by some other substance, okay, and first produced at the working electrode and then it reacts with the substance to be estimated. And what is the example given here is, first what happens is serous ion will give you seric ion plus electron, that is Ce3 plus gives you Ce4 plus electron, and the Ce4 plus is a intermediate. So in the intermediate kuda nammaloda substance vandu react panna. Our substance is nothing but Fe2 plus. Ferrous ion will react and that will give you ferric ion, Ce3 plus Fe3 plus, and the end point is detected in this method spectrophotometrically. Spectrophotometrically it is being detected. Is it okay? So I'll repeat this method once again. So if you take coulometric titration, there are two types of coulometric titration. One is called as primary coulometric titration, another one is called as secondary coulometric titration. Coming to primary coulometric titration, what happens here is the substance to be estimated will undergo direct reaction at the electrode. Direct reaction on the electrode will undergo pannu. So oxidation takes place. Fe2 plus will give you Fe3 plus electron, and the completion of the reaction at the end point can be directed amperometrically. This is primary coulometric titration. Coming to secondary coulometric titration, in this titration the active intermediate will be first produced at the working electrode. Cathode la modalla vandu உனக்கு ஒரு திங் வில் பி ஃபார்ம், இன்டர்மீடியட் வில் பி ஒரு இன்டர்மீடியட் சப்ஸ்டன்ஸ் முதல்ல ஃபார்ம் ஆகும். அந்த இன்டர்மீடியட் நம்மளோட சப்ஸ்டன்ஸ் கூட ரியாக்ட் பண்ணி நமக்கு தேவையான ப்ராடக்ட்டை அது ப்ரொடியூஸ் பண்ணும். அப்புறம் என் பாயிண்ட் வந்து ஸ்பெக்ட்ரோஃபோட்டோமெட்ரிக்கில் நம்ம கண்டுபிடிப்போம். இஸ் இட் ஓகே? ஸோ செகண்டரி coulometric titration is one in which an active intermediate is first produced at the working electrode. Then this combines with the substance to be estimated, and what happens then is that reacts with our working substance. That is the substance what we need to estimate. Okay, and a good example here is Ce3 plus gives you Ce4 plus, which is said to be a intermediate. Serous ion gives you seric ion plus electron. Ce3 plus gives you Ce4 plus electron, and this Ce4 plus is nothing but it is a intermediate, and this intermediate will react with the ferrous ion Fe2 plus to give you Fe3 plus. Fe3 plus is our product plus Ce3 plus will be formed. Is it okay? And the end point is detected spectrophotometrically. And coming to the application of coulometric titration, we have 4 different applications. neutralization titration. It is used in neutralization titration, which is nothing but acid-base titration, then precipitation titration, then complexometric titration, and last one is redox titration. And for today's class, I am going to take only acid-base titration. So application of coulometric is 4 applications are there, as it is used in acid-base titration, precipitation titration, complexometric titration, as well as redox titration. And only one application I am going to take for today's class, which is nothing but acid-base titration. Is it okay? So coming to acid-base titration, it's otherwise called as neutralization titration. For this titration, if you take a strong base or a weak base, that for the titration of a strong base or a weak base, the basic solution is first electrolyzed using a platinum electrode. So what happens here is the hydrogen ion generated at the platinum anode by oxidation of water. I'll repeat. So what happens if you are going to estimate the presence of strong base or a weak base, ஏதோ ஒரு base, only strong base எடுத்துக்கலாம் அல்லது weak base கண்டுபிடிக்கணும். Base solution is first electrolyzed using a platinum electrode. What happens there is the hydrogen ions are generated at the platinum anode by oxidation of water. So what's the reaction behind this? 2H2O reversibly gives you O2 plus 4H plus 4 electron. I'll repeat the process once again. So initially what happens there is, if you are going to estimate a strong base or a weak base, உனக்கு base மட்டும் estimate பண்ண நம்ம என்ன பண்ணணும்னா ஒரு basic solution எடுத்து electrolyze பண்ணணும் using platinum electrode. Hydrogen ions are generated at the platinum anode by oxidation of water. So what happens here is water reversibly gives you oxygen plus 4H plus 4 electron. இப்போ என்ன நடக்கும்னா இந்த H plus ions will be neutralized by the OH minus ions in the base solution. ஏன்னா நமக்கு solution வந்து only weak base அல்லது strong base. So கண்டிப்பாக என்ன இருக்கும்? OH minus ions will be there. அப்போ என்ன நடக்கும்னா இந்த water oxidize பண்ணி generate பண்ண அந்த H plus ions is neutralized by the OH minus ions of the base solution and water will be formed. And the end point is determined potentiometrically. And a potentiometer will be connected to that. So from the potentiometer, the reading will give you the end point. Is it okay? So I'll repeat this method once again. So acid base la strong base or weak base or இருந்துச்சுனா நம்ம என்ன பண்ணனும்னா ஒரு basic solution எடுத்து electrolyze பண்ணனும் using a platinum electrode. Hydrogen ion வந்து உனக்கு கிடைக்கும். எப்ப hydrogen ion will be produced by oxidation of water. Platinum anode la வந்து oxidation நடக்கும். So water reversibly gives you oxygen plus 4H plus 4 electron. Is it okay? And the generated H plus ions are then neutralized by the OH minus ion of the base. ஏன்னா நம்மளோட base வந்து weak base இருந்தாலும் strong base இருந்தாலும் நம்மளோட solutionல என்ன இருக்கும்? OH minus ions will be there. So அதை வந்து water வந்து H plus ions generated from water will be neutralizing that. So this the end point is directed potentiometrically. Then coming to the next one here, we have seen for base. Yeah, and if your titration is meant for acid னு வெச்சுக்கோயேன், உனக்கு strong acid or weak acid இருக்குனா நம்ம என்ன பண்ணனும்னா an acid solution containing 0.04 molar sodium bromide has to be taken. If you are going to estimate a strong acid or a weak acid, நம்ம என்ன எடுக்கணும்னா acid solution containing 0.04 molar sodium bromide is electrolyzed using a platinum cathode as well as a silver anode. இங்க என்னெல்லாம் எடுக்கணும்? அங்கே எல்லாமே platinum electrode தான் எடுக்கும். Anode platinum, cathode platinum. இங்கே என்ன பண்ணணும்னா platinum cathode and silver anode has to be taken if it is an acid. அது மாதிரி solution பார்த்தீங்கன்னா acid solution containing 0.04 molar sodium bromide வந்து எடுக்கணும். இங்கே என்ன நடக்கும்னா hydrogen ion will be generated at the platinum cathode by reduction of water. அங்கே என்ன நடக்கும்? oxidation of water நடக்கும். உனக்கு வந்து H plus ion வந்து generate பண்ணும். இங்கே வந்து என்ன நடக்கும்னா cathode ல reduction of water will takes place. So water plus 2 electrons gives you 2 OH minus plus H2 gas will be liberated. OH minus ion plus H2. Anode ல என்ன reaction நடக்கும்னா the reaction is nothing but the Ag plus is your anode. So Ag will react with Br minus. Br minus is nothing but நம்ம என்ன solution போட்டிருக்கோம்? NBr போட்டிருக்கோம், NaBr போட்டிருக்கோம், sodium bromide போட்டிருக்கோம். So அதில் உள்ள Br minus will react with the anode to give you AgBr plus electron. AgBr plus electron. Now what happens is the silver bromide formed a protective coating and prevents the interface from H plus ion formation. H plus ion formation நடக்க விடாம இது பார்த்துக்கும். அப்புறம் என்ன நடக்கும்னா the generated OH minus ion is then neutralized by the H plus ion of the acid solution. சரியா, இந்த H2 வருதுல அதுலேருந்து ஜென்ரேட் ஆகாமல் இது பார்த்துக்கும். இப்போ என்ன நடக்கும்னா the OH minus ions are neutralized by the H plus ions of the acid solution and the end point is detected potentiometrically. I'll say the second point once again ma. So neutralization of acid can be done, also base can be done. முதல்ல நான் சொன்னது வந்து பேஸுக்கு என்ன பண்ணோம், டைரெக்டாக வந்து வாட்டர் வந்து ஆக்சிடைஸ் பண்ணி உனக்கு H plus ions கொடுத்துரும். அதில் டைரெக்டாக யார் கூட ரியாக்ட் பண்ணிடும், OH minus ஆஃப் த பேஸ் கூட ரியாக்ட் பண்ணி வாட்டர் ஃபார்ம் பண்ணிடும். இது பொட்டன்ஷியோமெட்ரிக்கில் கண்டுபிடிச்சிடலாம். பட் ஆசிட்க்கு என்ன பண்ணணும்னா, ஃபார் ஆசிட் யூ ஷுட் நாட் டூ இன் தேட் வே. நம்ம 2 எலக்ட்ரோடு எடுத்துக்கிறோம், ஒரு பிளாட்டினியம் கேத்தோடும் ஒரு சில்வர் ஆனோடும் எடுக்கும். சொல்யூஷன் என்னென்னா ஆசிட் சொல்யூஷன் கண்டெய்னிங் 0.4 மோலார் சோடியம் புரோமைடு வந்து வச்சு எலக்ட்ரோலைஸ் பண்ண வச்சிடுறோம். சரியா, ஸோ முதல்ல என்ன நடக்கும்னா ரிடக்ஷன் டேக்ஸ் பிளேஸ் ஆன் வாட்டர் வந்து கேத்தோடில் என்ன நடக்கும்னா ரிடக்ஷன் வந்து நடக்கும். ஸோ H2O plus 2 electron reversibly gives you OH minus plus H gas will be liberated. ஆனோடில் என்ன நடக்கும்னா நம்ம போட்டிருக்க சொல்யூஷனில் என்ன இருக்குன்னா NaBr இருக்குது. ஸோ அந்த Br minus will combine with Ag to form you silver bromide. இது எதுக்குன்னா this forms a protective layer and prevents the interface from H plus ion formation. சரியா, உனக்கு அதுலேருந்து H plus ion formation வந்துடாமல் இருக்கிறதுக்கு வேண்டி இது பண்ணிகிட்ருக்கோம். அதுக்கப்புறம் என்ன நடக்கும்னா இந்த ஜென்ரேட் ஆகிருக்க OH minus ion வந்து will neutralize the H plus ion present in your acid solution and the end point is detected potentiometrically. So we can have a short recap of the thing what we have seen for today's class. First we have seen the apparatus setup of controlled potential coulometry. There are 4 things: coulometric cell, potentiostat, coulometer assembly and current measuring device, and the application of controlled potential coulometry. We have seen 3 applications we have. Then we have seen coulometric titration. And what do you mean by this coulometric titration? Na enna onnum illa constant current coulometric analysis க்கு இன்னொரு பேர் தான் என்னன்னா coulometric titration. இங்க நம்ம titrantலாம் யூஸ் பண்ண மாட்டோம். எலக்ட்ரான் கேத்தோட் ஆனோட்ல அந்த வரக்கூடிய இந்த எலக்ட்ரான் ஜெனரேஷன் தான் இந்த மெத்தட்ல நம்ம பார்க்க போறோம். So types of coulometric titration, there are 2 types of coulometric titration. ஒன்னு primary coulometric titration, இன்னொன்னு secondary coulometric titration. Primary coulometric titrationல பாத்தீங்கன்னா direct நம்ம estimate பண்ற substance வந்து எலக்ட்ரோட டைரக்டா ரியாக்ஷன் undergo பண்ணும். Secondary coulometric titration பாத்தீங்கன்னா உனக்கு முதல்ல ஒரு intermediate ஃபார்ம் ஆயிட்டு அந்த intermediate தான் என்ன பண்ணும், reacts with your substance to be estimated. Then application of coulometric titration, we have 4 application. Neutralization titration, then it is used in precipitation titration, complexometric titration, also it is used in redox titration. So only one application we are going to see for today's class. It's nothing but acid based titration and it's otherwise called as neutralization titration. இதில் வந்து பார்த்தீங்கன்னா base strong base or strong weak base இருந்தால் we have to follow one method, and if it is a strong acid or a weak acid we have to follow another method. So this is some about the application of coulometric titration. I think you are able to follow what I taught you for today's class. Thank you for listening. Continue studying. Thank you, ma.